Kummersdorf Proving Ground, Brandenburg, March 1943. Major Kurt Hoffman stands in the testing bunker, his hands resting on an American machine gun that shouldn't work as well as it does. The weapon is heavy, almost cumbersome, its receiver machined from solid steel with a precision that seems excessive. He pulls the trigger. The sound is methodical, measured, a steady rhythm of 400 rounds per minute that continues without variation for 2 full minutes. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. When Hoffman releases the trigger, he places his palm against the barrel jacket, warm but not dangerously so. The water circulating inside has absorbed the heat, just as the American designers intended. His assistant, Lieutenant Franz Weber, consults his notes and speaks with the careful tone of a man reporting something that contradicts expectations. 2 minutes, continuous fire, 473 rounds expended, 0 malfunctions, barrel temperature 180 degrees Celsius, well within operational parameters. Hoffman nods slowly, but his expression betrays confusion rather than satisfaction. This should not be possible with such manufacturing tolerances. Look at the machining marks, Franz. They didn't even bother to polish them smooth. The weapon appears almost crude, yet it performs flawlessly. Weber leans closer, examining the receiver through a magnifying glass. Every surface shows tool marks from milling operations. The Germans would have finished these surfaces to a mirror shine, removing any imperfection that might create stress points or fouling. The Americans simply left them raw. And yet, Hoffman continues, it fires hour after hour without failure. We've put 8,000 rounds through this specimen in the past week, not a single stoppage that wasn't caused by deliberately damaged ammunition. The Browning model, 1919. The Americans called it their workhorse, and German intelligence had captured dozens of them across North Africa and later in Italy. What seemed, at first glance, to be an outdated design, heavy, water-cooled, operating on principles established in World War I, revealed itself through testing to be something far more significant, a weapon built on a manufacturing philosophy that German engineers were only beginning to understand. The story of how German weapons specialists came to respect, then puzzle over, and finally acknowledge the superiority of American mass production methods began not with a single captured weapon, but with a systematic misunderstanding of what made a machine gun effective in modern industrial warfare. Germany entered the Second World War with what many considered the most advanced small arms in the world. The MG-34 and its successor, the MG-42, represented the pinnacle of machine gun design. High rates of fire, quick-change barrels, universal mounting systems, German optical sights were legendary. The nation's machinists were trained to tolerances measured in hundredths of a millimeter. Precision was not merely a technical standard, but a point of national pride. When the first American weapons fell into German hands in North Africa in 1942, the initial reaction was dismissive. The M1919 seemed primitive by comparison. Its water cooling system alone weighed more than an entire MG-42. Its rate of fire barely exceeded 400 rounds per minute, less than half that of Germany's machine guns. The design dated to 1919, making it almost a quarter century old by the time it saw combat in the Second World War. But something didn't add up. American infantry units equipped with these supposedly inferior weapons were holding their ground and often advancing against German positions. The Browning proved maddeningly reliable in conditions that would have sent German armorers scrambling for replacement parts. Desert sand, mud, extreme cold. The American gun simply continued firing. Major Hoffman had been assigned to the Weapons Testing Command at Kummersdorf in January 1943 with a specific mandate: determine why American small arms, despite appearing technically inferior, were proving so effective in combat. His background made him ideal for the task. Before the war, he had worked as a tool and die maker in Stuttgart, then served as a technical liaison with Mauser. He understood both the theory of firearms design and the practical realities of manufacturing. The first M1919 to reach Kummersdorf arrived in February 1943, captured during the Tunisia campaign. It came with 200 rounds of American 30-06 Springfield ammunition, 3 spare barrels, and a water can. The gun showed evidence of hard use. The bluing was worn from the receiver, sand had etched the external surfaces, and the wooden handles bore the scratches and dents of field service. Hoffman's team began with a complete disassembly. What they found challenged every assumption about proper weapons manufacture. The receiver, rather than being a precisely fitted assembly of separate components, was machined from a single steel forging. The operation would have required hours on a milling machine, cutting away metal until only the receiver remained. It was the opposite of German practice, which emphasized stamped components and modular construction to save time and material. Weber measured the receiver walls with calipers, 8 millimeters thick in places. Our receivers are 3 millimeters and achieve the same strength through better steel alloys and heat treatment. This is wasteful. Hoffman studied the massive piece of steel. Wasteful, yes, but consider what it provides. Dimensional stability that doesn't depend on perfect heat treatment. If the steel isn't quite right, the extra thickness compensates. If machining isn't perfectly square, the mass absorbs the stress. They've built in redundancy at the material level. The bolt assembly revealed similar philosophy. German machine gun bolts were complex mechanisms with multiple small parts, rollers, cams, locking pieces, each precisely fitted. The Browning bolt was essentially a solid steel block with a few carefully positioned holes and pins. Fewer parts meant fewer potential points of failure, but it also meant more weight and what appeared to German eyes as crude simplicity. The barrel presented perhaps the greatest puzzle. German doctrine emphasized quick-change barrels, specifically because high rates of fire generated heat that degraded accuracy and eventually damaged the bore. The Browning took the opposite approach, a heavy barrel surrounded by a water jacket that could hold nearly 4 liters of water. The water absorbed heat, allowing sustained fire without barrel changes. Hoffman ordered a firing test to determine the practical limits of this system. They mounted the M1919 on its tripod, loaded a belt of 250 rounds, and began firing. The gun settled into its characteristic rhythm, roughly 8 rounds per second, each shot distinct and separate. After 2 minutes, they stopped and checked the water temperature in the jacket. 85 degrees Celsius, still well below boiling. They continued. 500 rounds, 1,000, 1,500. The water began to steam gently from the overflow tube. At 2,000 rounds, nearly 5 minutes of continuous fire, the water reached boiling point. Still, the gun fired without malfunction. Weber recorded the results with visible frustration. At this rate of fire, the barrel will last indefinitely. The water cooling is completely effective. A single barrel could fire 20,000 rounds before requiring replacement. Hoffman nodded. Now compare this to our system. The MG-42 fires 1,200 rounds per minute, but requires a barrel change every 250 rounds of sustained fire. In the time this Browning fires 2,000 rounds, our gun would need 8 barrel changes. Which system is actually superior? The question hung in the cold air of the testing bunker. German engineering had optimized for maximum instantaneous firepower. American engineering had optimized for sustained reliability. Both approaches worked, but they reflected fundamentally different assumptions about how machine guns would be employed in combat. Over the following weeks, Hoffman's team subjected the captured M1919 to every test they could devise. They fired it in freezing temperatures until ice formed on the water jacket. They deliberately introduced sand into the action. They used ammunition that had been stored in humid conditions. They bent the feed mechanism slightly out of alignment. They replaced the carefully measured German gun oil with common motor oil. The Browning continued to function. The most revealing test came when they attempted to induce a failure through poor maintenance. German machine guns required regular cleaning and lubrication, according to strict schedules detailed in technical manuals. Soldiers were trained to field strip their weapons daily, clean each component, and reassemble everything to precise specifications. Failure to maintain this regimen resulted in stoppages and mechanical failures. Hoffman ordered that the M1919 be fired without any cleaning or maintenance, beyond adding water to the jacket when needed. 1,000 rounds. 2,000. 5,000. The gun accumulated a coating of carbon residue. The action became gritty with powder fouling. Still it fired. At 8,000 rounds, Weber finally reported a malfunction, a failure to feed caused by accumulated gunk in the belt feed mechanism. They hosed down the gun with water, wiped it roughly with a rag, added oil, and resumed firing. It worked perfectly. "This is not possible," Weber said, more to himself than to Hoffman. "Look at the fouling. Look at the carbon buildup. By all engineering principles, this weapon should have jammed thousands of rounds ago. Yet it functions." Hoffman had been taking notes throughout the test. The tolerances. Franz, measure the clearances. In the action, Weber produced his calipers and micrometers. The measurements told the story. The German MG42 had been designed with tight tolerances, gaps between moving parts measured in tenths of a millimeter. This precision maximized efficiency and contributed to the high rate of fire, but it also meant that any fouling or debris could cause binding. The Browning's internal clearances were massive by comparison, sometimes a full millimeter or more between components. "These gaps are enormous," Weber reported. "Any German weapons inspector would reject this as substandard. The parts are essentially loose." Hoffman smiled grimly. "Loose? Yes, but consider what that looseness provides. Powder fouling accumulates, but doesn't jam the action. Sand gets in, but passes through. The weapon isn't precise. It's forgiving. They've traded perfect efficiency for massive reliability. The implications extended beyond a single weapon. If American manufacturing philosophy emphasized forgiveness over precision, then their entire production system could tolerate variations that would cripple German manufacture. A factory that produced M1919s didn't need master machinists for every operation. The design absorbed imperfections. Less skilled workers could produce functional weapons. Production could scale more easily. Hoffman requested additional captured American weapons for comparison. Over the next months, Kummersdorf received M1 Garand rifles, Thompson submachine guns, Colt 1911 pistols, and Browning automatic rifles. Each weapon underwent the same systematic analysis. Each revealed the same underlying philosophy: robust design with generous tolerances, heavy construction that provided inherent stability, and simplicity that sacrificed some performance for reliability. The M1 Garand proved particularly instructive. German weapons specialists had long admired the American semi-automatic rifle's gas operation system, but they puzzled over its weight, nearly 5 kilograms loaded, compared to the Kar 98K's 4 kilograms. Disassembly revealed why. The Garand's receiver was machined from a massive steel forging, much like the Browning machine gun. The operating rod was a solid steel bar. Every component seemed to be overbuilt by German standards. Weber conducted a torture test similar to the one performed on the M1919. He fired one captured Garand repeatedly without cleaning, deliberately exposing it to mud and sand, and even bent the operating rod slightly with a hammer. The rifle continued to cycle and fire. "When we bend our rifle's gas tubes, they fail immediately," Weber noted. "This one absorbed the damage and compensated." The pattern became clear. American weapons designers operated from an assumption that combat conditions would be harsh, maintenance would be imperfect, and users might not be expertly trained. Rather than demanding that soldiers and conditions meet the weapons' requirements, American weapons were designed to meet soldiers where they were. The engineering philosophy was fundamentally democratic in a way that German precision manufacturing was not. This realization troubled Hoffman deeply, though not for technical reasons. If American weapons could be produced by less skilled workers, tolerate imperfect conditions, and still function reliably, then American industry possessed a massive advantage in total war. Germany's emphasis on precision required skilled machinists who took years to train. Bomber raids that destroyed machine tool factories couldn't be quickly remedied. American factories could tool up faster, train workers faster, and scale production to levels Germany couldn't match. He wrote in his report to the Weapons Testing Command Headquarters, "The American M1919 represents not merely a different engineering solution to machine gun design, but a different philosophy of industrial warfare. Where we have optimized individual weapon performance, they have optimized production system performance. Where we have created weapons that perform brilliantly under ideal conditions, they have created weapons that perform adequately under all conditions. The implications for prolonged conflict are sobering." In April 1943, Hoffman was granted permission to conduct a comparative trial between the M1919 and Germany's own MG-34, the predecessor to the MG-42. The MG-34 was considered a masterpiece of firearms engineering, beautifully machined, fast-firing, accurate. Both weapons would fire 5,000 rounds over a 3-day period under field conditions with maintenance, limited to what an average infantry soldier could perform. As if you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you're watching from today. The trial began on a cold morning with intermittent rain. 2 gun crews, each consisting of a gunner and assistant, were assigned their weapons. Neither crew was told they were being evaluated comparatively. They simply received orders to fire at targets according to a schedule that simulated combat employment. The M1919 crew was taught basic operation, how to load the belt, when to add water to the jacket, and how to clear simple malfunctions. The MG-34 crew consisted of trained Luftwaffe armorers who knew their weapon intimately. Day 1 proceeded without incident. Both weapons functioned well. The MG-34's higher rate of fire, 800 rounds per minute compared to the Browning's 400, drew appreciative comments from observers. The German gun sounded crisp and professional. The American gun sounded slow, almost lazy by comparison. By the end of the first day, each weapon had fired 1,500 rounds. Day 2 brought complications. The weather worsened. Heavy rain mixed with sleet. The firing range became a mud pit. The MG-34 began experiencing intermittent failures to feed. The gun crew performed immediate action drills, cleared the stoppages, and continued firing. The M1919 continued its steady rhythm without interruption. By evening of day 2, the MG-34 had experienced 11 stoppages. The Browning had experienced none. Day 3 was colder, with temperatures dropping below freezing overnight. When firing resumed in the morning, the MG-34's lubricant had thickened in the cold, causing the bolt to move sluggishly. The crew cleaned the weapon, applied fresh oil, and resumed firing. The M1919, its action kept warm by the heat from firing, and the water jacket functioned normally. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The trial concluded with a clear result. The MG-34 had fired 4,700 rounds with 32 stoppages and required 2 hours of maintenance to keep it running. The M1919 had fired 5,000 rounds with 3 stoppages, all caused by defective ammunition, and required only basic water refills and cursory wiping down of external surfaces. Hoffman's report was blunt. In sustained fire under field conditions, the American weapon proved 3 times more reliable than our own. This conclusion was not what his superiors wanted to hear. Germany had invested enormous resources in developing the MG-34 and 42. These weapons were considered evidence of German technical superiority. To admit that a supposedly primitive American design outperformed them in practical reliability was to question fundamental assumptions about German engineering excellence. The response from Berlin was dismissive. Oberkommando der Wehrmacht, the armed forces, High Command, returned Hoffman's report with annotations suggesting that the test conditions had been unfairly chosen to favor water-cooled weapons. The report was classified and filed. No changes to German production or doctrine followed. Hoffman was quietly transferred to other duties, but the truth couldn't be suppressed at the front lines. German soldiers who captured M1919s often chose to use them in preference to their own weapons. Despite the logistical challenges of obtaining American ammunition, Soviet forces, when they captured Brownings through Lend-Lease or from Germans who had themselves captured them, passed them to elite units. The weapon's reputation for reliability became legendary among those who actually had to depend on their machine guns in combat. Lieutenant Werner Schultz, serving with the Wehrmacht's 397th Infantry Division in Italy, wrote in a letter home in December 1943, "We took an American position yesterday and found 2 of their machine guns intact. Heavy things require water like a steam engine, but they fire forever without complaint. Our MG-42 is faster, but needs constant attention. If you stop cleaning it for even a day, it jams. The American gun doesn't care whether you maintain it or not. It simply works. I would trade 3 of our guns for 1 of theirs if I could get ammunition." This sentiment appeared repeatedly in captured correspondence and prisoner interrogations. German soldiers appreciated their MG-42's firepower, but they recognized that firepower meant nothing if the weapon stopped functioning at a critical moment. The Browning's reliability provided a psychological confidence that the technically superior German weapons sometimes could not match. Hoffman, though transferred from Kummersdorf, continued to think about the implications of what he'd learned. In his personal notes, never intended for official reports, he wrote, "We Germans are taught to believe that precision equals superiority. Our education system, our apprenticeship programs, our entire industrial culture emphasizes the pursuit of perfection. A master craftsman in Stuttgart can machine parts to tolerances that seem miraculous. We are proud of this, and rightly so. But the Americans have discovered something we missed. In war, perfection is the enemy of good enough. A weapon that works 90% as well but can be produced in half the time by workers with half the training will win the war of attrition." This is not a technical insight. It is a strategic insight, and we have failed to grasp it. The strategic implications became brutally clear as the war progressed. By 1944, German production of all machine gun types, MG-34, MG-42, and older models still in service, totaled approximately 350,000 units for the entire year. American production of just the M1919A4, the vehicle-mounted version, exceeded 400,000 units in the same period. The United States was simultaneously producing 1919A6 guns for aircraft, M250 caliber machine guns, and maintaining full production of other weapons. The difference wasn't merely in numbers, but in the sustainability of production. German factories required skilled workers who were increasingly scarce as casualties mounted and men were drafted from industry into the Wehrmacht. Allied bombing disrupted supply chains for specialized components. Quality control became difficult to maintain as pressure for quantity increased. American factories, by contrast, could train new workers quickly because their designs didn't require master-level skills. Women and men previously working in entirely different industries could learn to operate the machines that produced Browning receivers and other components. The M1919's manufacturing process reflected this democratic approach to production. Unlike German weapons that required careful hand-fitting of components, the Browning was designed so that any receiver could accept any bolt, any barrel, any feed mechanism. Parts were interchangeable because the tolerances were loose enough to accommodate variation. A factory in one state could produce receivers, another could make barrels, a third could assemble them, and everything would fit together. German weapons, with their tight tolerances, often required final fitting by skilled armorers. By 1944, German intelligence had accumulated detailed reports on American industrial capacity. The numbers were staggering and barely believable. A single factory complex in Connecticut, Colt's Patent Firearms Manufacturing Company, was producing more M1919 machine guns per month than all of Germany's manufacturers combined. The factory operated 3 shifts, employed over 15,000 workers, and delivered weapons that met specifications without requiring individual inspection and adjustment. Hoffman, by then serving as a technical advisor to Army Group B in France, reviewed these intelligence summaries with growing despair. He understood what they meant. Germany had lost the war of production before the first shot was fired. The Americans hadn't needed to build better weapons, though in reliability they arguably had. They'd simply built more weapons faster with less skilled labor. The mathematical inevitability was crushing. In June 1944, when Allied forces landed in Normandy, they brought with them thousands of M1919 machine guns. German defenders noted with grim recognition the steady, reliable rhythm of American fire. It wasn't fast or dramatic like the MG-42's buzzsaw. It was inexorable. American positions could maintain suppressive fire hour after hour, day after day, because their guns didn't break down and their supply system delivered ammunition in quantities that seemed inexhaustible. German after-action reports from Normandy repeatedly noted the same phenomenon. American infantry units would establish a base of fire with their machine guns, then maneuver under that protective umbrella. The machine guns never seemed to jam. They never seemed to run out of ammunition. They never seemed to require the pauses for barrel changes that German doctrine mandated. The sustained fire created a psychological pressure that was as effective as the actual bullets. One captured Wehrmacht manual from this period, intended for training troops to face American forces, included this remarkable passage. The enemy's machine gun fire, while not as rapid as our own, is extraordinarily sustained and reliable. Do not assume that pauses will occur for barrel changes or maintenance. American crews can maintain continuous fire until ammunition is exhausted. Plan movements accordingly and do not wait for natural breaks in fire that may not come. This was an admission, buried in tactical guidance, that German weapons doctrine had been superseded by American manufacturing philosophy. The German answer to the machine gun problem had been to fire faster and change barrels more frequently. The American answer had been to fire slower, but never stop. In prolonged combat, the American answer proved more effective. The story of German engineers examining captured American weapons represents a larger tragedy of the war, the gap between German technical excellence and strategic reality. Germany produced brilliant individual weapons, sophisticated optics, advanced metallurgy, and precision manufacturing. But these achievements occurred within an industrial system that couldn't scale to meet the demands of total war against enemies who had mastered mass production. The M1919 symbolized this gap. To German eyes, trained to admire precision, it appeared crude, heavy, simple, tolerant of imperfection. But these apparent flaws were actually features. The weight provided stability. The simplicity enabled mass production. The tolerance of imperfection meant that factories didn't need perfect conditions or perfect workers to produce perfect weapons. They could produce good enough weapons in quantities that overwhelmed any advantage German technical sophistication might provide. Hoffman survived the war and returned to Stuttgart, where he resumed his career as a tool and die maker. In interviews conducted in the 1960s, he reflected on his wartime work examining American weapons. His comments reveal a man who had learned a painful lesson about the relationship between engineering and strategy. I spent years learning to machine parts to tolerances measured in microns. I was proud of this skill. I believed it represented the highest form of industrial craftsmanship. And then I tested the American Browning and realized that they had found a better way, not better machining. Their tolerances were crude by our standards, but better thinking. They had asked a different question. Not, how precisely can we build this? But how reliably can we make it work under the worst conditions? The second question turns out to be far more important in war. In the decades after the war, weapons design gradually shifted toward the American philosophy. Loose tolerances, robust construction, and forgiveness of imperfect conditions became standard. The AK-47, developed in the Soviet Union, embodied these principles even more extremely than the Browning. Modern military rifles are designed to function when dirty, when poorly maintained, when handled by minimally trained users. The lesson that troubled German engineers in 1943, that perfection is the enemy of good enough, became conventional wisdom. The M1919 itself remained in American service through the Korean War and into the early Vietnam era. Weapons produced in the 1920s were still firing reliably in the 1960s, a testament to the durability of overbuilt simplicity. The last M1919s were finally retired in the 1970s, replaced not because they had worn out, but because more modern designs offered advantages in weight and ease of transport. Even then, many weapons in storage remained functional after 50 years of existence. German weapons, by contrast, largely disappeared from frontline service by the 1950s. The MG-42 was redesigned as the MG-3 to meet NATO specifications, but even this evolution incorporated lessons learned from studying weapons like the Browning: looser tolerances, simpler maintenance, greater forgiveness of field conditions. The pursuit of absolute precision gave way to pursuit of practical reliability. The irony, which Hoffman noted in his later years, was that German manufacturing capabilities had been applied to the wrong objective. German industry could have produced reliable, simple, mass-production weapons if that had been the goal. The skills existed, the facilities existed. What didn't exist was the philosophical framework to value reliability over refinement, quantity over quality, and democratic accessibility over technical excellence. These were choices, not capabilities. Germany chose precision and paid the price. When Hoffman died in 1978, among his possessions was a notebook from his time at Kummersdorf. The final entry, dated December 1944, read, "We tested the American machine gun and found it lacking in every measure of excellence we valued: rate of fire, precision, efficiency, elegance. Yet it won the war, while our superior weapons lost it." This paradox contains a lesson I am still learning. Excellence is contextual. In war, the excellent weapon is the one that keeps firing when everything else has failed. The Americans understood this. We did not. Perhaps that is why they sit in victory and we in ruins. The M1919 was never the fastest machine gun, never the lightest, never the most technically sophisticated. What it was, consistently and reliably, was present and functioning when needed. It absorbed the imperfections of combat, of maintenance, of ammunition, of operators, and continued to deliver sustained automatic fire. This was enough. In total war, it was more than enough. German engineers examining captured Browning machine guns discovered that American manufacturing had solved a problem Germany hadn't fully recognized: how to arm a mass conscript army with weapons that would function regardless of conditions or skill level. The solution wasn't better metallurgy or tighter tolerances. It was worse metallurgy used more generously and looser tolerances designed intentionally. It was engineering in service of production rather than production in service of engineering. The test reports from Kummersdorf, buried in archives for decades, tell a story of slowly dawning recognition. Early reports focus on technical specifications and performance metrics. Later reports begin to grapple with the strategic implications. The final reports, written in late 1944 as Germany's situation became increasingly desperate, simply document American production figures with a sense of numb astonishment. 150,000 M1919 machine guns produced in November 1944 alone. More machine guns in 1 month than Germany produced in an entire year. The numbers had their own eloquence. They spoke of an industrial system that had long ago surpassed German capacity and was still accelerating. They spoke of an enemy that didn't need technical superiority because quantitative superiority was achieving the same result. They spoke of a war that had been lost in Detroit and Seattle and Connecticut before it was lost in Normandy and the Ardennes and Berlin. Hoffman's final report to OKW, submitted in January 1945 and immediately filed without action, concluded with these words: "The American M1919 machine gun is not a superior weapon by our standards of evaluation. It is, however, a superior solution to the problem of arming millions of soldiers in sustained industrial warfare. We have spent this war building exceptional weapons for exceptional circumstances. The Americans built adequate weapons for all circumstances. History will record that we were correct in our engineering, but wrong in our strategy. The Browning will outlast the MG-42, not because it is better, but because it is enough, and there are so many of them." 2 months later, as Soviet forces closed on Berlin, Hoffman destroyed his papers and surrendered to American forces. Among the few possessions he kept was a small metal tag from a captured M1919 serial number, stamped into steel. He kept it, he later explained, as a reminder that in war, the most dangerous enemy is the one who understands what actually matters. The Americans understood. We did not. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.